Hello everyone and welcome to Mathify, and today we are going to discuss the EMQ Set 2 exclusive mathematical questions, where I am going to list down some of the very interesting questions on non-routine mathematics. So let's get started. So here we have the first question of the set, where it asked, consider the sequence 1 minus 4 plus 7 minus 10 plus 13, where the 2nth term is minus 2 times 3n minus 1 and the 2n minus 1th term is 6n minus 5. Find the sum of first 2001 terms. So feel free to pause the video and try it yourself. So let's solve the question. So it's a clear case of summation. So what I've got the idea that if we paid the terms, we will get a constant. So if you observe the series closely, we have 1 minus 4 if we take that in pair, and 7 minus 10, and then we have 13 minus 16, and this goes down. Here we have the constant of minus 3. Here also we have a constant of minus 3. So we can compile it up into 6n minus 5 minus 2 times 3n minus 1, where n belongs to 1 to 1000. Why 1000? As we have a total of 2001 terms, if we pair them up, we will get total of 1000 pairs plus one odd term, and that term will be of 2n minus 1 type, that is 6n minus 5. And here 2n minus 1 will be 2001 and n equal to 1001. So here we have 6n minus 5 equal to 6001. So we will add this up later. So let's solve this summation first. So here we will get 6n minus 5 minus of 6n plus of 2, and that will be minus 3, n belongs to 1 to 1000, and that will be simply minus of 3000. So the answer will be 6001 minus of 3000, that will be 3001. So here we have the second question of the set, where it asked, a number k is called Chintu number if k is greater than y, where y equal to x square minus 5x plus 9 upon x square plus 5x plus 9. Find such Chintu number which satisfy the range 42 to 69. So here we have to find out the number of k's which satisfy in the range. So feel free to pause the video again and try to solve it. So let's solve it down. Clearly it's a simple question on quadratic. Here y will be x square minus 5x plus 9 upon x square plus 5x plus 9, and that will be x square y minus 1 plus 5x y plus 1 plus 9 times of y minus 1, and that will be 0. It's a simple quadratic equation in variable x. So here d will be obviously greater than 0, as this equation gives real solution. Here we have b square minus 4ac, that will be greater than 0, and that will be 5 times of y plus 1 times square minus of 4 times of y minus 1 square. As a and c is same, it will be minus of 36, my mistake, and that will be greater than 0. Then we will get 25y square plus 50y plus 25 minus of 36y square plus 72y minus of 36 greater than 0, and that will be minus of 11y square plus 1122y and minus of 11 greater than 0. So here we can multiply with negative, so to get the coefficient of the highest degree positive, and that will be 11 of y square minus of 122y plus 11, which will be less than 0, and then when we solve it, we will get 11y minus 1 y minus 11 less than 0, and here we get the range of y, and that will be 1 by 11 to 11 and with close bracket. So here I forgot to give the equality, so it will be equality here. So let's get back to the question, where it gives us that y is less than k and we have to find k, which belongs to 42 to 69. So we can clearly see that y satisfy k with every number of 42 to 69. So we can say that k belongs to 42 269, it satisfies all the number. So that will be 69 minus 42 plus 1, which is the formula. So to get 18 as answer, as it satisfy all the numbers. So here we have the third question of the set, where it says the statement there are exactly 4 integer values of n for which 2n plus y upon n minus 2 is itself an integer. For how many values of y in range of 1 to 20 the statement is true. So it's a beautiful question on number theory. Please pause the video and try the question yourself. So let's start the solution. So here it given that 2n plus y upon n minus 2 is an integer. So let's simplify this expression into 2 times of n minus 2 plus y plus 4 upon n minus 2. I can write this down into like this, and then it will be 2 plus y plus 4 upon n minus 2, and this will be I, which is an integer. To satisfy this, we need this expression, that is y plus 4 upon n minus 2, to be an integer. And in the question given that n has 4 distinct integral values for which they satisfy. So I can say that y plus 4 has 4 factors. And when y plus 4 is divided by n minus 2, we have 4 different integers of this whole expression. We have 4 integers, that is ABCD. Then what can I say that y plus 4 is a natural number with 2 divisors, so that it will have 2 positive factor and 2 negative factor. So with that we will get 4 factors. So I need y plus 4 with 2 divisors. And what type of numbers have 2 divisors? Prime numbers. So y plus 4 belongs to prime number. So we can list down some of the numbers. So that will be y plus 4 equal to, let's say, 2, 3, 5, 7, 11, 13, 17, 19, 23. So then we can write that y equal to minus of 2, minus of 1, plus of 1, 3, 7, 9, 13, 15, and at last 19. But in the question it's given that y belongs to in the range of 1 to 20. So we have to cancel out some of the terms, and at last we will have 1, 2, 3 to 19, which is total of 7 terms, which is the answer. And now to verify it, what we can do, we can put this number back to the mother equation to see that if it satisfies or not. So in the mother equation, that is 2n plus y upon n minus 2, let's put any random number such as 7. So we have 2n plus 7 upon n minus 2, that is 2 plus 7 plus 4 upon n minus 2, that is 11 upon n minus 2. We have to check that only 4 integers of n satisfy this. So we can say that n here satisfy at minus of 9, then we have 3, then we have 13, and also we have 1 here. So only these 4 numbers satisfy this, which means 7 is one of the answer. Like this, if you want, you can recheck all these numbers, it all satisfy. So at last, here we have the fourth question of our set, where it says it is given that x minus 42 times x minus 69 equal to a has a real root o and p. Find minimum real root of equation x minus o times x minus p plus a equal to 0. So it's a simple question of algebra and quadratic. So feel free to pause the video and try to solve the question. So here we have x minus 42 times x minus 69 equal to a. We can write it down as x square minus x times 42 plus 69. We don't really need to do the heavy calculation because we can do that later. At first we should do some algebraic part of it. So here then it will have plus of 42 times 69 minus of a, that is equal to 0. So here we have roots o and p. So what we can say that o plus p equal to 42 plus 69, which is minus of b by a, Vieta relation, and o times p, that is equal to 42.69, that is C by A. Again, we had a relation. So we got some relation in O and P. So let's get back to the question. And here we have to solve x minus O times x minus P. So we can directly say that x minus O times x minus P plus A equal to 0, and that is x square minus of O plus P plus OP plus A, that is equal to 0. So if we back substitute the terms of O and P in numbers, we have x square minus of 42 plus 69 times of x plus 42.69 minus of A plus of A equal to 0. So here we can say that A got cancelled, and we have the roots of this equation, let's say alpha and beta. So we have alpha equal to 42, beta equal to 16, which is the answer of the question, as we have to find out the real roots of the equation, and that will be 42 and 69. So that's all we have as for today in the EMQ set 2. We are going to release more EMQs and more type of problems. So please be connected to us by our YouTube channel or by Telegram or by Discord server. Links in the description below. Thanks for watching.